following video is a step-by-step guide on how to create a fiberglass pond lining. Fiberglass pond linings are superior forms of waterproofing for concrete and other substrates. Offering long-term durability and full water resistance, they're perfect for fish and other aquatic life forms. A pond lining is an internal surface coating designed to contain the contents, namely water and other ecological components. It also acts as a barrier to prevent external contaminants in surrounding soil from entering the pond, an important feature if the pond is expected to contain fish. Resin Library offers a range of kits for fiberglass pond linings. These are available in a range of sizes, and they're used by professional and DIY installers alike. Before conducting any work, ensure you have the correct PPE in advance and ensure the work is being performed in a well-ventilated area. This video shows the layers of concrete, primer, fiberglass laminate and top coat used to create a fiberglass pond lining. It should be noted that specific design details around the perimeter edges should be decided on a case-by-case basis. To install a fiberglass pond lining, it's necessary to create a clean, dry and mildly rough surface. This may require some sanding, jet washing or an equivalent. It's important to let the substrate dry out before applying the laminate. The second step is to apply a primer. Generally considered optional, this is a thin, resin-based layer designed to improve the adhesion between the laminate and the base substrate. It also acts to block external contaminants from seeping into the pond. Primer should be applied in a thin coat on a flat surface of around 0.5 kilograms per square meter. However, some concrete layers are quite porous, so more primer may be needed. The third step is to apply the fiberglass laminate. Laminating involves the application of catalyzed polyester resin to glass fiber matting on top of the pond substrate. Glass fiber should be cut into workable sections and placed in the pond in advance. Overlaps between each section of glass fiber should be around 5 to 10 centimeters. This is to ensure that a seamless laminate is created. Polyester resin requires a catalyst, typically MEKP, to initiate curing. MEKP catalyst should be added in a 1 to 4% volume to weight ratio to the polyester resin. Concentrations outside of this range will lead to a substandard laminate. So for example, for every 1 kilogram of polyester resin to be used, use between 10 and 40 milliliters of MEKP catalyst and thoroughly mix it in. Lower concentrations, typically 1 to 2% of MEKP, are preferred for warmer temperatures, whilst higher concentrations, typically 3 to 4% of MEKP, are preferred for colder ones. Catalyzed polyester resin should be used within a 15 to 20 minute window to avoid premature curing. Prepare workable amounts of catalyzed resin and, if possible, practice in advance to ensure concentrations lead to a good quality laminate. The table on the right shows the different amounts of catalyst or MEKP to add per kilogram of polyester resin. These can be used to help you decide what amount of resin to use and what concentration of catalyst to achieve. It's also important to work out what amount of resin to add per square meter of glass fiber matting. Adding the correct amount of polyester resin per square meter of glass fiber is important in creating a high quality laminate. The amount of resin depends on the grade and the number of layers of laminate used. For single layer 450 gram chopped strand matting, typically 1.1 kilograms per square meter of catalyzed resin is used. For 600 gram chopped strand matting, 1.5 kilograms per square meter is typically used. For dual layers, the amount of resin per surface area of substrate covered by matting is effectively doubled. So for instance, for 450 gram CSM, 1.1 kilograms of resin per square meter is used, and 2.2 kilograms per square meter of resin is used in total for both layers. Likewise, for 600 gram CSM, 1.5 kilograms per square meter per layer is used, with 3 kilograms per square meter in total being used for both layers. It should be noted that polyester resin must be catalyzed before use, and an extra 10 to 15% of catalyzed resin can be used if needed. Catalyst should be accurately measured before being carefully poured into the resin. It should be thoroughly mixed using a clean mixing tool. You should expect to see a slight colour change in the resin to show that the catalyst has been blended in. The resin should be applied to the glass fibre matting using a polyester roller, commonly used for larger areas, or a brush for smaller or more complex areas. The aim is to drive the resin into the matting with moderate pressure, ensuring that it's fully saturated and free from air bubbles which can cause defects. You can see the air bubbles in this clip in the white sort of patchy areas. This is a sign that extra resin is needed and extra pressure to drive them out. It's important to remove these because they'll introduce structural defects in the laminate and limit the lifetime. The second step in the laminating process is to consolidate the laminate using a paddle roller. This is to further ensure a consistent finish to the laminate and to help drive out any remaining air. Good laminators typically and repeatedly apply mild to moderate pressure with the paddle roller to ensure a high quality finish. As you can see, the laminate is now free of any white patches and is generally very consistent in both colour and texture. Allow the laminate to cure for a period of 2 hours or more. Once cured, carefully inspect the laminate for defects prior to applying top coat. These include exposed fibres, pinholes, splits and cracks, droplet formation, and generally insufficient coverage. Resin top coat should be prepared and applied in the same manner as the polyester resin. Also known as flow coat, it's intended to provide an added layer of protection to the laminate via enhanced abrasion resistance, full waterproofing, as well as providing a cosmetic layer. One exception here is that you don't use a paddle roller to apply the top coat, you just focus on the polyester roller and the paintbrush. Top coat, also known as flow coat, also requires an MEKP catalyst to initiate curing. MEKP catalyst is added in a 1 to 4% volume to weight ratio to the top coat. Concentrations outside of this range will lead to a substandard finish. Lower concentrations, such as 1 to 2% of MEKP catalyst, are preferred for warmer temperatures, whilst higher concentrations of 3 to 4% are preferred for colder ones. For example, for every kilogram of top coat to be used, between 10 and 40 milliliters of MEKP catalyst should be added and thoroughly mixed in. This is more so than the standard polyester resin because it's got a higher viscosity. Catalyzed top coat resin should be used within a 15 to 20 minute window to avoid premature curing prior to application. It's wise to prepare workable amounts of catalyzed top coat, if possible. Practice in advance to ensure concentrations lead to a good quality finish. As you can see in the table on the right, there's recommended quantities, volumes of catalyst to add per kilogram or per quantity of resin, as well as different concentrations. A workable amount of top coat should be prepared. For most users, this will be around 1 to 2 kilograms, enough to cover 2 to 4 square meters of laminate when applied in a 0.5 kilogram per square meter layer. Adding the correct amount of resin per square meter of laminate is important in creating a high quality finish. The recommended amount is 0.5 kilograms per square meter of cured laminate. An extra 10 to 15% of the catalyzed top coat may be required in some instances in more uneven surfaces. Catalyst should be accurately measured before being carefully poured into the top coat. It should be thoroughly mixed using a clean mixing tool. The top coat should be applied inside a 15 to 20 minute window to prevent premature curing. The top coat resin should be applied to the laminate using a polyester roller, commonly used for larger areas, or a brush for smaller or more complex areas. The aim is to cover the laminate with a thin layer of the resin that's evenly dispersed across the surface. It should be seamless and consistent in all areas. Once the top coat has been applied, allow it to cure for a minimum of 48 hours. Rinse the pond with a water supply and allow it to soak for several hours. Drain it and repeat that process up to 3 times. You can then fill the pond with water and then introduce fish and other aquatic life forms. This video is for general informational purposes only. It does not constitute laminating or any other construction related advice. Resin Library is not liable for any outcomes. The use of information linked to this video is at the user's own risk. The content in this video is not intended to be a substitute for professional laminating advice or any other construction related advice. Users should not disregard in obtaining professional health and safety advice when viewing this video.